Question 12, Form 2, Mathematics Form 2, Chapter 11, Isometric Transformation. The diagram on the right shows triangle ABC. Here it is, triangle ABC, which has three transformations. Starting from the triangle ABC, there is P, labeled as P, and turn to undergo three kinds of transformation, from P to Q, Q to R, R to S. So there are three types of transformation. Okay. A. Describe the transformations. Describe. So we're going to do this step by step. First, we're going to describe from P to Q only, P to Q, which transformation then the process go, which transformation. Yeah, we know some of the transformation like rotation, translation, and reflections. But in this case, P to Q, analyze it, which transformation that it took from here to get there. Can you imagine this? What kind of transformation it took to get from here to there? Yes, it is. It is a reflection. It's like a mirror. So it took transformation of reflections. So how do we going to write the answer? We're going to write it like this. We're going to write for those who cannot imagine this, how the reflection happen, as usual, I got this magic paper, which is called a transparent plastic. So hope it might help your imagination. So can you see the trace of the triangle there? Okay, and you know what? If we do the reflection, means that we're going kind of like folding like this. When we do reflection, we're going to folding like this. Can you see how am I folding the plastic? So you see, it's going to be there. And another thing for you to mention is, where is the axis of reflections? Where is the axis? Because we need to state the axis of reflection. Either it is here, or here, or here, or somewhere else. Obviously, it is here. Why? Because it divides the axis and the distance from object to axis, from axis to image with the same distance. So it is why it's going to be, the axis is going to be in a middle between the object and the image. You got the idea? Good. In case you forgot about the reflection, you just need to go back and take to know back the properties of reflection, like being stated here. Okay. So let's move, and yeah, we do the reflection. So from here, P to Q, we're going to describe like this. We're going to describe P to Q what kind of transformation? Reflection. Reflection. Okay, first we state the kind of transformation, that is a reflection. Then second, we also need to state the axis of reflection. In this case is on the line X, on the line X equal to 4. Okay, this line, here it is. We need to state the line. Okay, that is line S4. Okay, now from Q to R, how do we going to describe the transformation? What kind of transformation that it took to get from here Q to here R? Can you imagine? So as usual, here is the piece of plastic that are going to help much to understand this. So here it is, we got Q to R. So it's going to, imagine it going to be from here to there, here to there. Okay, without having to rotate, without having to reflect. This time the orientation is the same one, but only moving on the other, being in other coordinate, without orientation, So it just moved from here to there without orientation. So what kind of transformation is it? Yes, it is a transformation of translation. If you forgot about the properties of translation, also so you have to check it back, all the meaning and the properties on your textbook. So how do we going to write this? So we're going to write Q to R. Translation. Okay. Kind of transformation is translation, and know what, we need to state how much the move takes, okay. Start from, let's say, this point B, and it takes how many? 1, 2, 3, 4. It takes 4 boxes from B prime to get there, B double prime. Okay. Downward. If downward mean it refer to which axis, either x axis or y axis. Yes, if go downward, it refer to y axis. Like this point to downward here to -2. Okay, so clearly it move on y axis downward. So we're going to state it like this. When it comes to y, you still remember this. How do we write the translation? Up here we put the how many move on the x axis, and down here we're going to put how many it move on y axis. This time we're going to because it takes 4 boxes downward on y axis, we're going to put that 4 here, down here, at below here. Okay, so you know what, if we go down, if it moves down, we're going to put negative. If it goes up, we're going to put positive. Like this case, from Q to R, it go down, so we need to put integer negative. So it means negative means go downward. How many? 4 boxes, 4 steps. Okay. How about y? How about x axis? How many it move on x axis? It move none. Because it straight from up here to down here without moving left or right. Just straight, just only one way down here. So it got nothing to do with x axis. We just put 0 to tell that if it doesn't move to either left or right. Okay, this is how we state translation. So next one, from R to S. What kind of transformation that it took? Okay, from R to S, yes, we already know it took transformation of rotation. Let me enlarge it for you. Okay. So where is the plastic to help your imagination? Sorry. So here it is, the plastic. Now from R to S, which kind of transformation that it took? Translation, no, because the orientation is different. The reflection, no, because it didn't overlap B. I don't know how to call this. B double prime, B triple prime, maybe triple prime. Okay, no translation, no reflection. Then what it is a rotation. Yes, it is a rotation. So let me from which center? Here it is. They already done it for you. K triple prime. There it is, the center of rotation from R to S. So I'm going to stick the needle there, so it won't move, but only rotate around at the center K. So you kind of imagine like that. Something wrong somewhere. Give me a minute to analyze this. Sorry, it is my mistake. K is for another question, for next question, B. So it got nothing to do with center of rotation. This K is not center of rotation for R to S. So do not confuse. Not confuse. So I'm not going to tell you how to find center of rotation from R to S. You already know the process. You already know the skill that it takes. Yes, it takes the skill of what we call it, the skill of perpendicular bisector. In case you forgot, then please watch back my previous video about how to find perpendicular bisector. So after I did perpendicular bisector, and all I got is the center of the rotation is there, right at this point. Can you see that? On the end of my tips of the pen, 5, which is the coordinate 5, 1, 5, 1. There it is. But we are not sure yet. We need to get a help with this plastic. Let's see, either we pinpoint the center of rotation correct. So I'm going to stick a needle there, so it will rotate all around, and let me see either the center is correct or not. So yeah, either rotate clockwise or anti-clockwise, doesn't matter, because if we do both, will it end up at the same place? Ta-da! You see? Ta-da! And if we go anti-clockwise, ta-da! So here it is, telling us that this center is correct. This center is for the rotation. So how do we describe this? We're going to describe R to S. R to S kind of transformation is 90 degree. You used to learn how to describe rotation, correct? Rotation. First we state the how many degree it turns. Okay, 90 degrees. And then second, clockwise or anti-clockwise. In this case, it take the short one, the short turn, that is 90 degree clockwise. clockwise. At what center? Sorry, rotation. We need to state rotation. And also we need to state the center of the rotation. Then we state the coordinate 5, 1. This is how to describe from R to S. Okay, so remember how to write things here. For each kind of transformation, they got their own way how to tell things. So take a note. Put it on your mind. Okay. Some of you might think that, can we do anti-clockwise? Can we describe anti-clockwise? Will there be a mark? Will there be will it correct to describe like that if we go anti-clockwise? Yes. Why not? We're going to get to the same place. So it is okay to tell the other one. That is R to S. It takes 270 degree. 270 degree, but this time you have to put anti-clockwise. Anti-clockwise rotation, still the same process, the same transformation. There is rotation, comma, center, the same center, 5, 1. So it is up to you. It doesn't matter anyway. But usually we take the short one, the short turn. Now let's go for B. If the point K triple prime is the image of point K, the image of point K, state the coordinates of the object K, the coordinates under the same transformation. Under the same transformation. Okay. Means that this K, somewhere around here, I don't know, we don't know yet, is undergo the same process from P to Q, Q to R, R to S. And this S is, in this case, is K triple prime. You got the idea? So we need to trace back from, the idea is we need to trace back from K triple prime, from here to here, then here to here, then here to back to the origin. It's what we call K. We need to find this coordinate. Where is it going to be? You got the idea? So let's do reverse. Let's do reverse. Let's reverse the process. Let me enlarge it for you. So, okay. So this K triple prime represent this S. S. So S, if we do the reverse, we'll get R, which is at the center. So the idea is K going to rotate back to its origin with the center there. So as we stated before, here to here it takes 90 degree clockwise, correct? So if here to here we need to do 90 degree anti-clockwise, then we get back to R. And so does this. From A to K triple prime, we need to do 90 degree anti-clockwise rotation. that with a little help from, this time we're going to need this. Still remember this? So need to be always with all the tools to learn mathematics very well. Huh? If you don't have one, go buy one. Huh? Buy two, buy three, buy many. It doesn't matter. The many, the better. So, okay. So we're going to set this point of a protractor to right on the point of the center of rotation. Then we're going to, oh yeah, wait. There, like that. And we adjust this line 0 degree until we reach at this line. Yes, there is. Okay, so you see this point to this point. Now let's begin the count. Okay, so this point going to turn all the way around until 90 degree, anti-clockwise, 10, 20, 30, blah 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 blah, until 90. Here it is, 90 degree. And because it takes 3 box, 1, 2, 3, here also it's going to take 3 box, 1, 2, 3, and here it is, right at that point. Can you see that one? Right at that point. Huh? So from here it turns until right at that point, which is x equal to 8. Okay, we are not finished yet. We just come to S to R. We need to find the next journey will be R to Q. Okay, this is R, then we need to find Q. By translation, we coming down, it takes 4 boxes. Then coming up also we need to take 4 boxes, 1, 2, 3, 4. Okay, so there it is, represent for Q. Huh? Okay, and from this point back to, from Q back to P, we need to do reflection. We need to do reflection. Huh? On the same axis of reflection, that is x equal to 4 here. So if we do the reflection, we're going to, from it going to take the same distance, which is 4 boxes, 1, 2, 3, 4. Okay, and from from reflection, axis of reflection, also it's going to take 4 boxes, 1, 2, 3, 4. So here it is. Where does the K triple prime coming from? The first one, the object, the first one, the origin. Okay, so how to answer this question? Back to the question. If the point K triple prime is the image of point K, state the coordinates of the object K under the same transformation. So we just need to state the last one we need to do is state the coordinate. So we're going to state like this. Simple one. We just state the coordinate, which is read the x-axis first, that is 0, then read the y-axis, that is 4, and here it is. So we done all question 12, question number 12. So here it is. Then we got 4 marks, or maybe more, depend on how many marks they'll give to you.